Bismillahirrahmanirrahim. Assalamu alaikum. Dear students, my name is Ali. I'm your physics teacher, and in today's lecture we are going to learn how to solve the numerical problems of chapter number 5, gravitation, from the physics of 9th class. Students, before solving the numericals, we will learn few formulas which are going to be used in the numericals. You can see in the next slide that the first formula which we will use is force is equal to G m1 m2 by d square. Then for the value of G is equal to G me over r square, and for mass of earth we will use small g capital R square over capital G. For the value of gravitational acceleration at height we will use capital G capital M over r plus h whole square. Then for the orbital velocity we will use gr square root, and another form of this is value of orbital velocity at some height is v0 is equal to gh into r plus h square root. There are few constant values which we will use in the solution. Capital G is equal to 6.673 multiplied 10 raised to power minus 11 Newton meter square per kg square, and mass of earth is 6 multiplied 10 raised to power 24 kg. Radius of earth is 6.4 multiplied 10 raised to power 6 meter. Students, before solving the first numerical, I am going to read the statement of the numerical, which is: find the gravitational force of attraction between two spheres, each of mass 1000 kg. The distance between the centers of the sphere is 0.5 meter. So students, in our given m1 and m2 are identical, which is equal to 100 kg. The distance between their center is 0.5 meter, and we know the value of constant 6.673 multiplied 10 raised to power minus 11 Newton meter square per kg square. Our required is force of attraction between them. So for this purpose we have a relation, we have a formula for this, that force is calculated by F is equal to G m1 m2 by d square. Students, in the next case, as we know that m1 is equal to m2, we will take m1 m2 as m square, and F will be equal to G m square by d square. In the next step, we will put the values. The value of G is 6.673 multiplied by 10 or minus 11 into 1000 whole square divided by 0.5 whole square. So first we will take 1000 whole square, it will become 10 raised to power 6. We will solve it with 10 raised to power minus 11, and we will take the square of 0.5 whole square, it will be 0.25. Then students, we will divide 6.673 by 0.25. The answer will be 2.66 multiplied 10 raised to power minus 4 Newton will be the force of attraction between the spheres. So the statement of second numerical is that find the gravitational force between two identical lead spheres kept at 1 meter apart is 0.006673 Newton. Find their masses. So the distance is given is equal to 1 meter. The force is 0.006673 Newton is equal to 6.673 multiplied 10 power minus 3 Newton in scientific notation. Value of constant we already know. Our required is m1 and m2, which are identical, so they are equal. So we are going to use the formula F is equal to G m1 m2 by d square. Students, as we know m1 is equal to m2, again we will take it as m square, and by rearranging the equation will become m square is equal to f d square by g. Students, in the next step we will put the value of f 6.6 multiplied times 6.673 multiplied times per minus 3 into 1 whole square, which will become 1, divided by 6.673 multiplied 10 raised to power minus 11. As these minus 11 will shift to numerator, it will become plus 11, and we will solve it with 10 raised to power minus 3, it will become 10 raised to power 8, and 6.673 and 6.673 will be cancelled with each other. So m square will become 10 raised to power 8, taking square root on the both sides to get the value of m and m1, m2 is 10 raised to power 4 kg of each. Mass will be the answer. So in third numerical, the statement is find the acceleration due to gravity on the surface of Mars. The mass of Mars is 6.42 multiplied 10 raised to power 23 kg, and its radius is 3370 kilometer. So mass of Mars is 6.42 multiplied times power 23. Radius of Mars is 3,370 kilometer, which we have to convert it in meter before solving. Then the value of gravitational constant we know already in all the numericals. So G on Mars we have to calculate. We know the relation that to find the G on the surface is equal to Gm over r square, the mass of the Mars, and divided by radius square of the Mars. We will put the values in the next step. That 6.673 multiplied times power minus 11 into 6.42 multiplied times power 23 divided by 3370 multiplied times power 3 whole square. So you have to keep one technique in your mind, that it would be easy for all of you if you will solve the 10 raised to power 10's power separately and the other simple values separately. So we will solve 10's power minus 11 10's power 23, and we will take the 10's power the square as 3 multiply 2, not 3 square. So it will become 4.2841 multiplied 10's power 13 divided by 1.135 multiplied 10's power 13. They will cancel with each other, and by dividing the values we will get 3.77 meter per second square will be the gravitational acceleration on the surface of Mars. So as for the fourth numerical, the statement is the acceleration due to gravity on the surface of Moon is 1.62 meter per second square. The radius of Moon is 1740 kilometer. Find the mass of Moon. We have the given values and our required is mass of Moon. We will use the formula. Mass of Moon is equal to gr square by capital G. We will put the values of G on Moon 1.62 into radius of Moon 1740 multiply 10 to the power 3, because we convert the kilometer in meter and take the whole square of this value, divided by 6.673 multiplied 10 to the power minus 11. So on taking the square and multiplying the values and solving it with 10 to the power minus 11, it will become 4.9047 multiplied 10 to the power 12 divided by 6.673 multiplied 10 to the power minus 11. So answer will become, on dividing and solving 10 to the power 7.35 multiplied 10 to the power 22 kg will be the mass of Moon.